Hey everyone, so today we're going to analyze student performance CSV, and we'll start by importing the necessary libraries. So we have pandas as PD, which is used for data analysis. We have matplotlib, we have seaborn, which are used for visualization. We also have skline.compose, which we import column transfer, and the pre-processing import on hot encoder and standard scaler, which is used for the pre-processing the data before machine learning. We also have the pipeline, which is very useful, which makes our work easier. Also we have import the train test split. This is basically used in our modeling logistic regression model. We also have the matrix to evaluate how our model is, which is the accuracy score, confusion matrix, and the F1 score. We also have the cross-val score, just to know how the model generalizes our data well. So the next thing is we're going to load the data set, that is df pd.read csv. So we display the head of our data set. As you can see, we have gender, race, ethnicity, parental level of education, lunch. As you can see, all the columns. So our main aim is to determine whether these factors affect the education. So the first thing I did was finding the average score in order to get whether the student passed or failed column. So the average score, so df average score is equals to, so we put all the columns: math score, reading score, and writing score. So we find the mean and the threshold for passing or failing, which is 50. So I'm applying this threshold to that column. So lambda x pass, if x is greater or equal to the threshold is 50, you pass, else you fail. Now we display after we display, we can see the two columns have been added, that is the average score and the grade score. Then this is me just looking at the shape. There we have 1,000 rows and 10 columns. As you can see, this is our info. We have 1,000 null count. We have no missing values. We have object type and integer type of data. Yeah, so let's go to the data cleaning, right? So as we have seen, there is no null value. df.isNull.sum, that is the code to use. We also have no duplicated values. df.duplicated.sum, there are no duplicated values. So for the categorical columns, we have unique values in the gender column are female or male. We also have unique values in race or ethnicity column. We have group B, group C, group A, group D, group E. Unique values in the parental level of education. We have bachelor's degree, some college, master degree, associate degree, high school, some high school. We also have the unique values in grade column. We have pass or fail. So we continue. So this is just me looking at the statistics summary. So that is, we use df.describe. So we have reading scores are the highest scores, followed by writing and math. The spread of scores is similar across all subjects. As we can see, scores range from 0 to 100 in all subjects, with a significant number of students performing at both ends of the scale. The middle 50% scored between 57 and 77 in math. We have 59 and 79 in reading, and also have 57.75 and 79 in writing. EDA. So we start with the univariate analysis, where we also start with the numerical column. So this is just me looking at the distribution of the numerical columns. As you can see, most of them are left skewed. So all the score distribution are slightly left skewed, indicating most students scored on the higher ends. That suggests on average students perform well in each subject. Also, it's noticeable that most students achieve perfect scores in reading and writing compared to math. We also check for outliers. But as we all know, it's possible for someone to get 0 in a test. So I don't think we will have any outliers in this section. Some scores appear as outliers in the box plot, but since exam scores range from 0 to 100, these values are valid and not unusual in this context. Okay, so we have the heat map, plotting the heat map. This is just to see the relationship between numerical features. As you can see, all scores are strongly positively correlated. Average score has the highest correlation with reading and writing, which scores of 0.97. As you can see, there's a strong positive correlation between them. We also have a pair plot. The pair plot shows strong positive linear relationship between math, reading, and writing scores. This confirms high correlation among them, supporting the decision to either use individual scores or average scores to avoid multicollinearity. This is when it comes to modeling later in the video. We also have distribution between categorical columns. So let me just read the code. So here we're just plotting the axis, the figure with 4 subplots. That is fig axis plt dot subplot. We are plotting 3 rows, 2 columns. Fig size of equals to 22 and 18. So we are plotting first the first bar plot, where we're saying the first bar plot will be a hist plot. That is gender. We're just looking at the distribution of gender. Then we also have race, ethnicity. We also have parental level of education. So this is what we're having. Most students come from ethnic group C and D. We also have ethnic group A and E have the best number of students. We also have students' education seem to vary. Only master's degree, bachelor's degree have the least number of students. Most students have not taken the test preparation course. The proportion of female and male students is almost balanced. Most students have a standard lunch type. So we go to the univariate analysis. So this is just me taking the categorical columns, the categorical columns and also the scores columns, seeing how they affect each other. So we have a bit of graphs here. I'm just going to go to the explanation because I'm going to put the link to this GitHub repo. We have a bit of many columns here. So then I'll just explain what these columns had said, the insight I got. So the first thing was about the ethnic group, right? So we have the gender. So female students seems to have a good performance in writing and reading, while male students has a good performance in math. There is no male student who gets a 0 score on all exam, while there are female students who get a 0 score in math. That was my insight number 1. Number 2, we had about the ethnic group, right? So the ethnic group ethnic group E, students from this group tend to perform well in all subjects with particularly strong performance in math. Ethnic group D, we have in writing, students from ethnic group A show a level of performance that can be compared with group E. Ethnic group A, students in ethnic group A generally have lower performance across all subjects. C, we have the students from this ethnic group are the only ones who scored 0 on the math. Ethnic group D, students from this group consistently have lowest grades in the. We also have parental level of education. So we see student student whose parents hold masters or bachelor's degree often excel, whereas students with parents who have completed only high school tend to have lower academic performance. We also have influence of advanced parental education. Children whose parents have education beyond high school consistently have higher scores. We also have the preparation test scores. Students who completed the test preparation course tend to perform better than the others. So in general, we see this is a count plot of how for grade by gender. So we see the female have the better performance compared to male. Also, the male fail more than the female. So when you come to modeling, we say the pair plot shows math, reading, and writing score are strongly correlated. To avoid multicollinearity in logistic regression, which is the model we're going to use, we'll use the average score instead of all the three. So when modeling, we have the columns that we'll use, that is gender, race or ethnicity, parental level, we have lunch, we have test preparation course, we have average score, we have the grade. So we convert the categorical column to be one hot encoded, that is the grade column, to the numeric. So we take the column final df.log, which is take all the rows that column, then we map it to pass, it's 1, fail, it's 0. Then we split the features in the target column, that is x dot drop the column which we remain with other columns, and axis equals to 1, that means we are just dropping the column. Then y is equals to final df the grade now. So we split, so splitting, so x test, y train, y test, 10 test split, or x y, we have the test size, that is 0.2, random state 42. Okay, so here we're just applying the pre-processing steps. So that is, we have the numerical column, we have the categorical column, so we have the preprocessor. That is because before we model, we ensure all the columns are supposed to be in the way that in order for the machine learning model to recognize the pattern. So we make sure we change them. So for the numerical columns, we standardize, that is, have the standard scalar where we put them into a mean of 0 and standard deviation of 1. And also we apply one hot encoding to categorical columns. So the next thing is creating a pipeline with the pre-processing steps and creating the logistic regression model. So model pipeline steps equals to preprocessor. The preprocessor that we use, that is the standard scale one hot encoder. So after that, they're going to be passed to a classifier, that is the logistic regression. So we fit the x train and the y train, model.fit. So we have evaluation of the model, that is y train and y pred. So we are predicting the y train and also predicting the y pred. So model.predict x train, model.predict x test. We're also looking at the test accuracy and the train accuracy. So accuracy score, we check for the test, y test, y pred. We also check the accuracy score for the y train and y pred. So test accuracy 0.98. We also have the training accuracy 0.99. Model performance. So the interpretation is the model performs very well on both the training and test sets with a small difference in accuracy, right? So with the slightly higher training accuracy compared to the test accuracy suggests that the model might be slightly overfitting, though the difference is minimal. The model generalizes well, as evidenced by the high test accuracy, indicating it is able to make accurate predictions on unseen data. So we need to cross-validate to ensure that it is not overfitting. To ensure that our model is not overfitting, cross-validation is performed. Cross-validation splits the data into multiple folds, and the model is trained and evaluated on each fold. This provides a more reliable estimate of the model's performance of the unseen data. So the next thing we're going to do is cross-validation, just to make sure the model is not overfitting. So we have the scores, cross-val score, model, we put the model, x, y, then we are going to be validating it within 5 folds, and the scoring is accuracy. So print. So we're just looking at the scores. Here we can see that the first fall has 0.97, 0.2nd score 0.97, 0.99, third score 0. So the mean cross validation is 0.984. This means that our model has high and consistent performance across all folds. So here we're just plotting the confusion matrix. From this confusion matrix, we see that the model performs well, only 4 false positive, meaning the model only occasionally mispredicts students who fail as passing. We also have the F1 score, which balance between precision and recall indicates a very high performance between precision and recall, suggesting that the model is performing well in terms of both correctly identifying students who pass and minimizing false positive and false negatives. And that is the end. Thank you for watching. Also, if you want to check this notebook, I've put a link on my GitHub repo. Clone it, and any comments are allowed in this. Thank you.